this here, 0 is equal to, actually, can we, take out a 4, right? So if I divide every term by 4, I get 3x squared minus 20x plus 25. All right, this is a quadratic. We don't have much choices for factoring, but we got lucky on this one. This one factors. In the real world, most of the time, it doesn't factor into nice numbers. But we get lucky here. So, using the zero product property and playing let's make a 0, we get 2 answers. What are they? 5 and 5/3. Okay, remember, let's make a 0. We set it equal to 0. And solve, we get that. What are 5 and 5/3? Critical values. Okay, what do I do next? Chart x and v prime. V prime represents the volume. We have got 5/3 and 5. Both of these give you 0. So if something special is going to happen in this problem, it's going to happen at 5/3 or 5. Okay. All right. So let's see. That's 1 2/3. So I'm going to plug in 1 and 2. Okay. This is on the end here, so we could try 6/2. All right, need your help now. V prime. Here's V prime. If I plug in a 1 in here, what am I going to get? Say it again. I'm going to get a positive. Plug in a 2. I get a negative. We're getting down here, so I'm going to crank things up. Positive means the volume is increasing, then decreasing. So that means we have a maximum here. So we say, therefore, a max occurs at x equals 5/3, which is really 1 2/3 inches. Because V prime changes from positive to negative. And then finally, we got to answer the question. What was the question?
How big of a square?
How big of a square? So we can use dimensions, okay? So we can cut a square that is what? 5/3 inches by 5/3 inches, and that is the goal. Okay. Now, if you can do this with me, but I'm going to do a quick graph of the equation. You can just watch. And the graph says something like this. And the graph here says that if you pick any value here, then that causes you to have a square. And the one right at 5/3 gives you the area that's the most. All right, on Monday, we're gonna determine whether or not this size soda can is the best use of aluminum.